explanation on the uncovered syllabus in the exhaustion chapter, especially for the basic second sem students. In case of adsorption, I have covered some basic concept of the adsorption and also the definition of adsorption and causes for the adsorption, and based on the bond between the adsorbate and adsorbent, there are two classes of adsorption. Two. One is physical adsorption and chemical adsorption. So in the regular class, I already covered the definition of what is physical adsorption and what is chemical adsorption, or a physisorption or a chemisorption. Now let us go for discussion about the differences between the physical adsorption and chemical adsorption. Look at this, the PPT that is present on the screen. I given the representation, diagram representation. In case of physical adsorption, the adsorbate molecule held on the surface of adsorbent with a weak van der Waals force of attraction, whereas in case of chemical adsorption, the adsorbate molecules held on the surface of adsorb by strong bond, that is a chemical bond. See, this is a chemical bond observed on the surface of it. So based on that, now let us go for the how the difference of physical and chemical adsorption. The first thing is there's a nature of bonding. The adsorbate molecules held on the adsorbent by weak van der Waals force of attraction, whereas in case of chemical adsorption, the adsorbate held by strong chemical bonds. And the second difference is the enthalpy of adsorption. The enthalpy of adsorption means the amount of enthalpy or a heat content liberated when the adsorbent molecule held on the surface of adsorbent. That means adsorption being an exothermic reaction. So based on that now, if the substance undergoes a physical adsorption, the amount of heat liberated is found to be low. There is a low enthalpy of adsorption varying from 20 to 40 kJ per mole. Whereas in case of the chemical adsorption, since the adsorbate held on the surface of adsorbent is strong, therefore the high enthalpy of adsorption varying from 80 to 240 kilojoules per mole. Now the third point is reversibility. Means the adsorbate held on the adsorbent can be reversed or not. In case of physical adsorption, the adsorbate molecule can be easily reversed because of weak van der Waals force of attraction. Whereas in case of chemical adsorption, the adsorbate molecule held on the adsorbent is not possible to reverse it. That means we cannot deadsorb it. Then nature, it is not specific in nature and it is highly specific in nature. Means the same surface of the adsorbent can have any number of adsorbed water on the surface. That means either you can adsorb the CO2 on the surface of the charcoal, or you can adsorb NSC on the surface of charcoal. Like this, the different type of substance can adsorb on this. So it's not specific for the particular type of adsorbate molecule. But whereas in case of a chemical adsorption, the one surface made for only one type of adsorbate molecule. So it cannot take other molecules on the surface. For example, if you take the tungsten, it can absorb only hydrogen. If you take this platinum, it can nickel, it can absorb only hydrogen, whereas nickel cannot absorb CO2 gas or ammonia gas. That is what is highly specific in nature. Now, when you observe this fifth is structure. Means the layers on the surface of this physical adsorption, chemical adsorption. Here now, it forms a multi-layer. So you can expect a number of layers, first layer, second layer, third layer. Number of layers can expected on the surface of the physical adsorption molecule. Whereas in case of the chemical adsorption, the surface covered only with a thickness, unimolecular thickness. Once the one molecule of this molecule is adsorbed on the surface of the adsorbent, and we cannot expect one more layer of this adsorbate to sit on the surface. That is what the specification concern to this nature structure. Now this the 6 point is the energy of activation. The energy of activation is low, and whereas the energy of activation is high. See, energy of activation is already discussed in case of chemical kinetics. It is a minimum energy the reactant molecule has to possess to undergo chemical reaction. Similarly, in this case, that every adsorbate molecule has possess a minimum amount of energy to get adsorbed on the surface of adsorbent. Whenever the molecule get adsorbed on the surface of adsorbent, if it's a physical adsorption, then the low energy factor is enough to get adsorbed on the surface of this adsorbent. Whereas in case of a chemical adsorption, the adsorbate molecule get more amount of that high energy of energy activation. That means they need more amount of energy to get adsorbed on the surface of adsorbent. Therefore, so the physical adsorption is having a low energy of activation, whereas a chemical adsorption has a high energy of activation. Now, what is the effect of pressure? See, if the it increases by increase the pressure, and pressure has no effect after the formation of unimolecular. That means the effect of pressure, if you take a gas, it is to be adsorbed on surface of a solid. When you go on increase the pressure of the gas, the more and more molecule approaches towards the adsorbent, and now it is go as you increase the pressure, that adsorption goes on increases. That's because of the increases now the more and more layers are expected to form on the surface of the sun. Whereas in case of the chemical adsorption, so once this the unimolecular thick layer form the surface of this whatever the pressure increase, no, there is no increase in the further adsorption of the molecule on the surface of adsorbent. Therefore, it's only unimolecular, whereas a multimolecular or more than one layer can expected for this. And whereas the effect of temperature, as I told you, that means it is being exothermic reaction. So increase in temperature or decrease in temperature always causes the change in the rate of adsorption or amount of adsorption. So since that it has a low energy of activation, the adsorbed molecule can readily adsorb on the surface of adsorbent at low temperature. That low temperature favors the adsorption. Whereas the energy of activation for the adsorb is very high. Therefore, when you increase the temperature, the energy of activation molecules goes up increases, and the more and more molecule get activated. Now, at high temperature is required, so it favors the adsorption of the adsorbent on the surface of adsorbent. So these are the important the differences between the physical adsorption and chemical adsorption. Now let us move on to next concept. That is, we have the different type of adsorption. Adsorption of a solution by solids adsorbent. Again, adsorption of a gases by the solid. Like these are the different type of adsorption. Among those, we shall have the concentration on adsorption of the solution by solid adsorbent. Means we prepare a solution. Into the solution you add adsorbent. You can see either a solute molecule or a solid molecule can adsorb in the surface of adsorbent. Now the adsorption of the solution by solid depends on the certain factors. This adsorption by solid from the solution depends upon the following factors. One is the nature of adsorbent, and second, the surface area of the adsorbent, and third, the nature of the solvent and solute, and fourth is the effect of temperature, and fifth is effect of concentration. Now let us go for the study of the effect of concentration first, then I'll come to the next one. So as you know, the effect of concentration, the variation of extent of adsorption with the concentration is given by Freundlich's equation, which for the adsorption from the solution is written in the form of x xy x upon y x upon y is equal to k into c raised to 1 upon n. So x upon m is equal to k into c raised to 1 upon n. That is the adsorption Freundlich equation that tells about the extent of the amount of adsorption of the substance on the surface of adsorbent depends on the concentration. That's what you can say. Based on the extent of adsorption, either a solute or solvent on the surface of adsorbent depends on the concentration. Okay. Now, based on that, now let me take we have the two important types of adsorption. One is a positive adsorption and a negative adsorption. Now let us consider a solution. When you say the solution, which consists of a two component, a solute and solvent. Okay. After having the solution, if you drop a activated wood charcoal into it, now it depends on the nature of solution. Means whether the concentrated solution or a dilute solution, the adsorption by the adsorbent may have the different types. So based on the term, we have the one is a positive deviation and second is a negative adsorption. In most of the cases, the solute from the solution is adsorbed on the surface of a solid adsorbent so that the concentration of the solute on the surface of a solid is greater than bulk of the solution. This is called positive adsorption. Means when you take the higher concentration, when you take this lower concentration, so in case of a lower concentration and where the solute molecule adsorb on the surface of adsorbent, when the solute adsorb on the adsorbent, the concentration of solute decreases in the solution. Therefore, the solution becomes diluted. Means the concentration goes and decreases if it undergo positive deviation, is it? So that's what I can say. That it says now the adjust so that the concentration of the solute on the surface of solid is greater than the bulk of the solution, and this is called a positive adsorption. Means we can simply can say if the adsorbent adsorbs a solute from the solution is called positive adsorption. This is a very simplified way of understanding the concept of positive adsorption. Similarly, when you go for the second is negative adsorption, in a few cases involving the solution of electrolyte, that means which can a solution prepared by dissolving electrolyte, the solvent from the solution is adsorbed by the adsorbent in preference to the solute so that the concentration solute in the solution increases. This is called negative adsorption. Means when you take this low concentration, means less amount of solute and more amount of a solvent present here. In such case, now in such case there is a variation observed the sol here. In case of a way that is the solvent is absorbed by the adsorbent preferred to the solute. That means when the solvent is absorbed, the concentration of a solution increases because the concentration of solvent decreases where the concentration of solute increases. Now in general the concentration goes and increases, so it is nothing but the adsorption of a solvent from the solution by the solid adsorbent is called negative deviation. So let us take an example from this now. So there's a when a dilute solution of KCl is taken with wood charcoal, it shows a negative deviation. See, as a negative deviation, dilute solutions. So dilute means here we have less amount of KCl, more amount of water. In this case, the solvent get adsorbed by the charcoal. Therefore, the solute remains in the solution. Therefore, the concentration goes increase. But a higher concentration of KCl, it shows the positive deviation. Means the concentration solute is high, but the concentration of the solvent is less. In such cases, a solute get adsorbed by the adsorbent. Hence, the concentration of the solute in the solution decreases. Therefore, it shows the positive deviation. So, this is all the two important types of adsorption, positive and negative adsorption. And you have to remember the examples. In case of positive adsorption, solute is adsorbed. In case of negative adsorption, solvent is adsorbed. So there's only the two difference we can say. Now let's go on the further discussion, the factors that affect the adsorption by the solid from the solution. And as I told you, the nature of adsorbent. So nature of adsorbent means that is what you are going to drop into the solution. The some adsorbent are effective in attracting certain substances to their surface than the other. Means there are the certain the adsorbent molecule, they prefer only particular type of adsorbent, but not all the adsorbent. That's what you can say, attracting certain substances to their surface, but not all. What all the present in that the system. Now the second is the surface area of adsorbent. Greater the surface area of the adsorbent, greater will be the adsorption. Means as I told you, if the surface, if the surface is more and more adsorption, if the surface is less and less absorption. So that's all depends on the number of active centers. Means number of the centers where that is the more residual forces which are causes the adsorption. If the more number of active center, more the adsorption. If the surface is, that can be obtained, that can be achieved by taking the adsorbent and finally divided state. In finally divided state, the more number of adsorbed centers are created. Therefore, adsorption goes and increases as the surface area of the adsorbent goes and increases. And nature of solute and solvent. So, say different solute dissolve the same solvent. See the word different solvent dissolve the same solvent or adsorb the different extent by same adsorbent. Adsorbent same, but it's a different type, number of different number of salt present in the same solvent, and again all these salt will not adsorb to the same extent on the same, but because the extent of the same adsorbent, let's say at a different extent adsorbent can affected on the surface of adsorbent, means some molecule may adsorb less and some molecule adsorb more, like this different solute dissolved in same solvent are adsorbed at to different extent by the same adsorbent. Okay, now we look at this. Non-electrolytes are adsorbed much more than the electrolytes from the aqueous solution by charcoal. Similarly, some solute dissolved the different solvents. In case of previous, different salts and same solvent. Here, that's a salt dissolved in a different solvent. Adsorption to the same extent can also be expected. So this is a, or in general, you can say the higher molecular mass adsorb readily and lesser molecular mass adsorb it less extent. That is what that depends on the molecular mass of the solute present in the solution. Higher the molecular mass of solute and more is adsorption. If the lesser the molecule of molecular mass of adsorbate and less is adsorption, there's the extent of adsorption on the same adsorbent depends on the what the nature of molecules, the not solute and solvent. And as you know, the effect of temperature, the increase in temperature results a decrease in the adsorption. As I told you, the adsorption is affected by temperature, and as I told in the beginning, the adsorption being an exothermic reaction we increase the temperature always decreases, means on increase in temperature, that is the adsorbate molecule acquires energy and there is a breaking of bond from the surface of adsorbent, and then what happens slowly the molecules are get dissolved, that's the going away from the surface of adsorbent. When you decrease the temperature, as a decrease in temperature always was absorption. So that's why as the energy of the energy possessed by the molecule goes and decreases, the molecules come closer to the surface of adsorbent and they get adsorbed readily. So this the effect of temperature can affect on the adsorption. So this is all discussion concerned to that. Now let us go for the one more discussion, the effect of dissolved substance on the surface tension of solvent. See, when you prepare a solution, first you are going to consider a solvent. Into the solvent you are dropping certain amount of a solute. And before going to this dissolution, and you have to measure what is the surface in the solvent which is taken for the preparation of solution. And you have to dissolve known mass of the solute in a given solvent, and after having the solvent in the after having the solute in solvent, now when you find out the surface tension of the solvent in the solution is found to be changes. Now this is due to the fact that the concentration of solute on the surface of solution is different from the bulk of the solution. Based upon their effect on the surface tension, we have the different types of substances are divided into three types. Now, so from the graph here, just to say, there is a change in the surface tension of the different substances. I have taken the three different types, and the characteristic property of those three types are drawn in the form of a graph. So along y-axis, this is the surface tension. Along x-axis, a constant solid taken in this one. Now the first type is type 1. This is concerned to graph 1, type 1. Those substances which increases the surface tension, though the increase in gradual and not large. This means no doubt there is a surface tension of the solid increases, not to the much extent. There is a gradual increase, there is upward movement of this one, the gradual increase in the surface tension of this one. And for example, the strong electrolyte dissolved in water exhibit this type of behavior. So this is shown by the curve 1. This is the type 1. That means an electrolytes are dissolved in a solvent, and where the surface tension of the solvent is goes on changes not much extent to so low extent, because the concentration of solid is going to be ionized, then number of solid molecules on the surface are going to be different unless. Now let's go for the second important is those substances which decrease the surface tension regularly and gradually they increase the concentration of the what solution. Now look at this graph 2. Now just to say this is a beginning. Now as you increase the concentration, slowly the decrease in the surface tension of the solvent. This is how we can say there is a regular and gradual increase in the concentration. At the same time, there is a decrease in the surface tension. That's what you can say. The surface tension solvent goes on decreases with the increase in the concentration of a solute in the solution. And example, you can see the non-electrolytes or weak electrolytes are dissolved in water, shows this type of curve 3, curve 2. This is what it is because they do not undergoing ionization, and as you know, the on to the surface of the solvent, the more and more molecules of the solvent may accumulate, so there is cause a decrease in the surface tension of the solvent. Now let's go for the third site of substances. Those substances which decreases the surface tension considerably even at very low concentration. Means that even very little amount of solid is added, and such type of substances which there is a much decrease in the surface tension of a solid is observed. For example, this type of behavior is exhibited by aqueous solution of soaps. Such substances are called active agents or surfactants. This type of a behavior is represented by the curve 3. This is see. Now, when you start even at very low concentration, see there is a continuous decrease in the curve. The curve shows there is a continuous decrease there, and at very low concentration, a much decrease the surface tension of solvent. Again, as the concentration goes on increase, this still is a goes on decrease in the what surface tension of solvent. This is what I observed. There is a very low concentration. Now, if a solid brings up the decreases surface tension, its concentration at the surface of a solution is more than the bulk of the solution. This type of behavior is called a positive adsorption, or the solid is said to exhibit a positive surface activity. As I showed you, that means in case of a positive adsorption, the solute molecule adsorb on the adsorbent. Here also same is observed in this case. Therefore, this type of solution shows the positive adsorption. On the other hand, if the solid brings about an increase in the surface tension, its concentration at the surface solution is going to be less than the remainder of the solution. This type of behavior is called negative adsorption. The solid is said to exhibit a negative surface activity. As you know that we say, there is a concentration solid is more. Now there is a change, negative adsorption. You think about adsorption as solvent molecule, and the concentration of what the solid good changes. So this is all regarding the discussion concerned to the effect of dissolved substance on the surface tension of the solvent. Total, you can conclude that the surface tension of the solvent depends on the concentration of solid dissolved, and depends on the nature of solid, and depends on the concentration solid you dissolved. There is a much change in the sometimes in case of some of the solid molecules slight changes or increases, in some of these cases decreases, and in some cases complete decrease observed now. So this is all regarding the factor or effect of dissolved substance surface tension.